So here we go. I need a new sheet of paper. All right, marginal analysis. So here I go. In business, if I say we're talking about a marginal function, what I mean is the derivative of that function. I couldn't say that in a business class. I could say it here because you guys have been studying derivatives for, well, a couple weeks now. Okay? So all I mean is derivative when I say marginal function. That might make sense to you because the derivative gives us the slope of a tangent line. And the slope of a tangent line, well, we're talking about a rate of change. You're going to see some of this here. So I'm going to take problem 20 from your book and use this to start explaining some of the examples. So this is section 3.5, number 20. They give me C of x. Do you know what C stands for? Cost. 15,000 plus 100x minus, and then it's 0.001x squared. And they say that x has to be between 0 and 200 for this cost function to be valid. And they ask me to determine a few things. First, we want to compute MC of x. Okay? That's the marginal cost. So I'm going to go ahead and do that. Well, first thing you need to know, when we say MC, marginal cost, for us that's exactly the same as C prime of x, right? The derivative. All right, let's take the derivative. What do we get? Well, what's the derivative of 15,000? 0, so forget that. What's the derivative of 100x? Just 100, right? So we get 100 minus, you can bring down the 0.001, but then you're going to end up multiplying it by what? By the 2. So how about I just write 0.002x? Is that okay? That's the marginal cost function. So this is problem 20. And the next thing problem 20 asked me was, let's talk about MC of 100, the marginal cost of 100. Okay? Well, that's going to be, you just plug in 100 minus 0.002 times 100. So I could do that without a calculator. It just moves the decimal point. 100 minus, this would be 0.2, because it moves it 2 places. So 100 minus 20 cents if we're working in dollars. I have to check the problem. I don't know yet, but I know that this is 99.8. Okay? So now the last thing the problem says is interpret. And here's where I need to open up the book. All right? I haven't done it yet, but let's do it. Anyone have a page number? 228. We have to interpret what this is we just computed. And you've been practicing this already. We just didn't really have a name for it yet. So here's problem 20. Kilomata Company producing stun stopper patio swings. Wow, what a great product, right? So it says that the cost of producing these swings is modeled like this, where X is the number of swings manufactured monthly. Pretty good business, right? Going to manufacture from 0 to 200 swings. What do you think those run for? You're going to sell those for? Come on, some of you guys are in marketing. What are you going to sell a patio swing for? How much? $300? All right. So they say X is the number of swings. Hey, by the way, I should say a couple things about this model. It says that you might make 0 swings some months, right? Like February. Well, I don't know, a Valentine's swing. I don't know. But there might be, right? Some month in Cleveland, you say, let's just shut the factory down, right? Hey, I have a question for you. What is C of 0? How come? There are still costs for your company, even if you shut down, right? Still got to pay the insurance, still got to pay, rent, okay? So there are fixed costs, but then there are costs. Why do you think this term is here, plus 100x? Well, for every swing, you got to pay $100, right? Materials, for instance. Labor, right? But then why would this happen? It's not revenue. This is costs. The more you produce, you do start getting some savings. Some people call it learning curve. Some people call it, well, the assembly line idea, right? But anyways, this is not an unreasonable model. I want to get that across. I'm not saying that this is an actual example, an actual company. I'm not saying that. But I am saying that one thing I do like about the book is that the authors put some thought into the functions that they use. Okay? All right, so now we're supposed to interpret MC of 100. Okay? So we've done this before, right? First we look for the units. So again, it's C prime of x, or dc dx, right? So what are the units for this 99.8? Well, cost is measured how? Dollars. Does it say that? It does. Production cost in dollars per what? Swing. All right, so I want to interpret what's going on here. And here's how I would do it. I would say, when 100 swings are being produced, each additional swing costs approximately how much? $99.80. Does that make sense? Here's the question they're going to ask you guys. Hey guys, we're producing 100. Should we up the production to 101 or 102 or 105? Well, you could. The original function says, oh, each swing costs $100. That's not true anymore, right? Because of this term. We're saving some money. Does this make sense to you guys? So this is what the marginal cost tells you. Okay? And actually, I think the next problem I want to do is an extension of this. 25, okay? Take the same function. Now we're going to determine what the book calls AC. I mean, it's not air conditioning, guys. I know you wish you had it, but
Average cost.
average cost. And then we're going to do MAC, which is marginal average cost, okay? So we're going to try and compute some of these things, okay? So once I get past there, I'm really now on problem 25. Okay, so AC of x, the average cost. And you know, it's one thing I've never had to explain in a math class is how you compute an average. Students always know. So if I say, hey, we have 3 tests. I got a 70, an 80, and a 90. What's my average? How did I get it? Add them up and? Why'd you divide by 3? Okay. So if I want to find the average cost for X swings, I'll take the cost function, which we call C of X, and what's the number of swings? X. That's what we called X, right? Does that equation make sense to you guys? It's the cost function divided by x. So for us, it's going to be 15,000 plus 100x minus 0.001x squared all over x. Okay? So that I could go ahead and compute now and interpret AC of 100. What's the average cost when I'm producing 100 swings? Get the calculator out for a minute. I want to show you guys some things we can do as we do this. Yeah, so do we have a cost function in here? Let's see. Not yet. Let's put a cost function in here. So the original cost function was 15,000 plus 100x minus 0.001 x squared. All right. And before I press graph, let me think about the window. It tells me what I want for x min and x max, right? We want 0 and we want what? 200. And I'm going to put a mark at 100 because that's what I want. And I don't care about the y's. Honestly, I know I'm not going to see anything. The cost is way off the map. But I know the shape of the graph. What shape is the graph? This cost function. What shape is it? It's got to be parabola, right? Opening which way, up or down? Why down? The x squared term has a negative in front of it, right? So, yeah, it's a downward parabola, but it might be really flat in this particular part. Okay? And what I can do, for instance, is I can compute by pressing trace. There we go. That y value, what's that represent? That's the cost of producing 100 swings. You guys with me? Okay. So if I want the average cost, this is kind of a neat thing to know about. If I go to y equals, I'm going to put the average cost in y2. I'm going to take that y1 and divide by x. Here's a nice way to do it. If you hit the variables key, you can choose y variables. For me, I have to press the right arrow to get to that menu. And then you can select any function you want. So if I take y1, which I had before, I can type that in. And now I could say divide by x. You could actually graph the average cost function. Now I'll graph it. I'm not going to see anything because my y's are really bad. But now if I press trace, see, here's x. Here's the cost of 100 swings. That's what we already got. But if I press the down arrow, it chooses the next function, y2. Look what it gave me. What's that? That's the cost per swing, right? The average cost. Actually, look, it divided by 100. That's very clear. Here's 24,990. So it's 249.9. Does that make sense? Okay. So AC of 100 is 249.9. And I know you didn't need all that calculating to do this, but it's nice to have for future examples, so I like to show it in class. All right. So how do we interpret? Well, again, when 100 swings are being produced, what would you say? The average cost per swing is $249.90. And this is where, if you take Dan's advice, he says, hey, we could sell it for $300. I heard him say that earlier. Is it worth it to be in this business? $50 profit on each of these? Maybe.
That's pretty good. Yeah.
Okay, maybe. There's more to think about for sure. All right, so now let's see. Oh, it asked for more. It asked me for the marginal average cost. All right, let's do that. So I want to find MAC of X. So what am I going to do? I'm going to take the derivative of AC of X. Take the derivative of that. Ooh, how am I going to do that? That's one way, the quotient rule. I'll be honest with you, I try to avoid the quotient rule. Ho-de high minus hi-de ho over ho. I mean, I know it. I'll use it if I have to. But I want to point out that in this problem there's an easier way, so let me show you. AC of X. Let's rewrite it. See, you can rewrite this as, well, separate fractions. 15,000 over X, right, plus 100X over X minus 0.001X squared over X. Do you guys see that? That's the same as what's above. You can split up a fraction into multiple fractions that share the same denominator. So then, let's rewrite it. AC of X is actually, I'm going to write this as 15,000 X to the negative first plus 100. And then this, what would this be? This would be minus 0.001X. You guys with me? So now what? Well, MAC of X, we're going to take the derivative. I should skip space. We take the derivative. So we get, let's see, it would be negative, because the negative 1 is going to come down, 15,000 X to the negative 2, bing, bing, and then bong is 1. How you guys doing, okay? You look tired. You look ready to go. 10 minutes. All right. Plus 0, right? And then minus 0.001. There's the marginal average cost function. Stop me if you have questions. Otherwise, I guess I'll just keep flying ahead. You guys with me? Oh, that's a good question. I did bing bing on the x negative 1 here. So bing, the negative 1 came down. And then bing, what's negative 1 minus 1? Negative 2. Okay? You guys see that? And then bong, well, it's just 1. And then here, that just went away. You guys with me? So now what do? Last thing they wanted. Find the marginal average cost of 100 and interpret it. All right, I'll do that. So let's see. MAC of 100. Well, it would be negative 15,000 x to the negative 2. That means over x squared, right? So I could write it that way. Minus 0.001. And if you work that out, I think you get negative 1 or negative point. Oh, I better work it out. So let's see. We have negative 15,000 divided by 100 squared, because we want to do x squared, and then minus 0.001. Okay, negative 1.501. Interpretation. Let's see if you guys can do that. Talk to each other and interpret this. Negative 1.501. So yeah, remember, marginal, this is a rate of change, right? This is a derivative. So I would probably interpret it like this. When, you know what I'm going to say first, right? When 100 swings are being produced, I could say the average cost per swing is what? Is decreasing by $1.50 for each additional swing produced. And a lot of times that's helpful. You know, you're trying to make a decision. Hey, we're making 100 swings. Should we up production to 120? Yeah, it's 20 more swings. You can kind of figure out, right? It's going to be another $30 or so. That's not exact. That's moving along the tangent line. That's approximate change in cost. Go ahead.
How would you interpret the average cost of X?
I did that before. Let's see. I just called it the average cost per swing. In other words, how much does it cost to for each swing, right? The total costs, remember we did that, was 24990, right? So it's not on here, but we do know that C of 100 is 24990, 24,990. Okay, that's the cost of producing 100 swings, 24,990. The average cost, that's telling you how much per swing. Does that make sense? Okay. Good. All right. Last one. Problem 35, and there's a lot to it. And I have to decide here, how much do I get away with? So, you read, you're going to want to turn to page 230 in a second because it's talking about this Kraft company price demand function, cost function. We did a problem kind of like this last week, and we worked it out. Let me give you a couple of hints that will help. By the way, here's what we're supposed to do. Find the revenue function, find the profit function. Then it says find the smallest and largest values that'll give you positive profit. I mean, you have to understand something. Remember, X, it says, is the number of frames that you're producing. Here's a company that produces picture frames. You make it. All right? If you only make one picture frame, you're going to lose big time. Or if you make 0 picture frames, no good, because you're not bringing in any revenue, right? And what's the startup costs for this company? $72,000. Okay? So there's big startup costs. So before I even start, I want to know, hey, how many do you think they're going to buy? How many do you think? And let's assume everything we produce they buy. All right? Let's assume that happens. That's oversimplifying it. But it's what we're going to do for this problem. So what you're going to want to use are some ideas for revenue and for profit. Do you remember what little p of x is? That's the price function, where x is the number of frames. So X might be, it might be your demand. You guys with me? So, here are some ideas I think that may help. The revenue function is going to be X times P of X. Does that make sense to you? Number produced times price. But then, notice what it asks me for. It asks me for smallest and largest values of positive profit. So you're going to have to write the profit function. Now, how did I do that? Revenue, which we just computed, minus costs. I'll put the video, I have this video online, and I'll try and feature it for you guys so you can take a look at it. All right? You guys have plenty to do over the next couple of days. There's no doubt about that. Sure, I'll flip to the homer.